Hi, my name's Daryl Peterson, and I'm the manager of the Applications Engineering Department here at Micromeasurements. This afternoon, I'd like to take a few minutes and talk about the do's and don'ts related to experimental testing and strain gauges. Do select the right strain gauge for the application in terms of the type and the environmental capability. We have thousands of different strain gauges to choose from, and we're here to help you select the right one that meets the requirements of your test. Whether it's indoors or outdoors or high temperature or low temperature, we'd be glad to walk you through the steps to make sure you select the right gauge that fits your application. Do choose the right elongation capability. You'll find strain gauges have a variety of different elongation capabilities based off of what they're made from. Cast polyimide and laminate polyimides, they typically have a higher elongation capability, where some of the reinforced laminate materials that are an epoxy or epoxy phenolic based typically are capable of a lower elongation, and we're here to help you select the right one. Do consider the required accuracy and precision of your measurement, and be careful of the 5% mentality. Sometimes customers will assume a 5% mentality, meaning that they're okay with their measurements agreeing to their theoretical values within 5%. And typically, as you start looking at a strain gauge measurement, you have small sources of error that can start to build up. So don't have that mentality that says that since it's a 1% error, I'm going to let it go. Try to correct for all those as much as you can, because the end product will be more accurate and should have better agreement to your calculated values. Do consider all environmental aspects before making the final choice, whether they are always or occasionally presented at the place where the strain gauge will operate. So it's one of those things where you sort of plan for the worst and hope for the best. You know, if you've got a strain gauge that's going to be outside, you've got to assume that it's going to be getting wet and it's going to see humidity, and we've got to do a good job of protecting that strain gauge from that environment. Do provide any additional environmental protection at the design stage. So what this means is you need to think about this early in the process. Not only you're looking at the gauge and the adhesive system and the lead wires, you're also thinking about what environmental coating am I going to apply over top of that gauge to keep it protected. Some environmental coatings provide excellent moisture protection, but they might melt at a low temperature, such as microcrystalline wax. Other environmental coatings may have a very wide operating temperature range, like some RTV silicone rubbers we offer, but they're not the greatest moisture barrier. So oftentimes you need to think about that very early in the design stage of your project. Do design an adequate over under load protection as well as protection from the mechanical damage. So what we're saying here is think about what the loading levels are, and also think about whether or not the strain gauge may see some physical contact. A strain gauge cannot have something come in contact with it, otherwise you would damage it. So you need to think about that. Some customers want to think a strain gauge is sensitive to strain in the normal direction, and that's not true. It's not sensitive to strain or pressure normal to the surface. It's the in-plane strain that it's sensitive to. This is a big one. Do remove soldering flux, which causes resistance drift and insulation resistance to ground problems. It's one of the most common problems that we run into in the Applications Engineering Department is customers that leave the flux behind because they don't realize they need to remove it. Even if it says no clean, that might be true for electronic components, but that is not true for strain gauges because we're dealing with such small resistance changes. So you want to make sure you get all the flux removed. That'll make sure that you don't have a path to ground, and also make sure that it doesn't create corrosion on top of the strain gauge or any exposed electrical connection. Do follow the bonding adhesive instructions, since failure to carefully follow these procedures can oftentimes result in a gauge debonding, or maybe a zero shift or drift, or even poor strain transmission into the grid, which can result in accurate strain readings for stress analysis or poor creep performance in transducers. Zero return is one of the most important characteristics to monitor when you're trying to evaluate an installed strain gauge. And oftentimes poor zero return is represented or is created by not properly installing the strain gauge. It could be that the adhesive was out of date. It could be that maybe the instructions weren't followed precisely for how to install it. It could be a variety of reasons, but one of the things we look for in terms of qualifying a strain gauge installation is the zero return. Do input the gauge factor value and the transverse sensitivity values in your data acquisition software. Otherwise, these errors can lead to errors in your total measurement, and it can lead to incorrect span settings with your instrumentation. This can be especially important whenever you're going to be using rosettes to correct for the transverse sensitivity. All of our data acquisition systems will allow you to input the gauge factor and the transverse sensitivity, and they will automatically correct for the gauge factor and for the potential error due to transverse sensitivity on the fly while you're taking the data. Do use the correct strain gauge protective coatings, otherwise it can result in gauge resistance drift over time due to a corrosive attack on the gauge foil. Sometimes we'll have customers that go find coating systems that they use for other things. It may be like a potting compound. It may be something that's an automotive material that now they're trying to use with strain gauges. And the problem with that is now you've got an electrically sensitive grid that's in that environment, and sometimes the inconsistencies or the chemical components that make up these compounds can provide an electrical path that could be a path to ground, or it could be some type of contaminant that could start attacking the grid of the strain gauge, in particular if you've got a voltage applied to it. So you do want to watch that, and if you're going to use an environmental coating that has not been qualified for strain gauge use, it's really up to you to do that. Do shunt calibrate the proper arm of the bridge, typically using Vichy bulk metal foil resistors, and by shunt calibrating the proper arm of the bridge, you can remove lead wire desensitization errors from a quarter bridge measurement. Some of the other videos we have on the YouTube channel, we talk about shunt calibrating at different locations, but if you shunt calibrate the dummy resistor, that will allow you to remove the effects of lead wire resistance with a 3-wire quarter bridge circuit. And this one kind of goes without, really it doesn't need to be said, but don't make the choice based only on price. Cost of ownership is much more important. And what I mean by that is the strain gauges are going to be the least expensive part of your entire measurement. You look at your time, you look at how many labor hours you have invested, you look at the instrumentation, you look at the environmental coatings, the lead wire and all of that, and typically you find the strain gauge is the least expensive part of the entire measurement. So don't make the strain gauge choice based off of price. Make it off of, does this strain gauge meet the requirements of my test? Do I think I can have a successful strain gauge measurement using this particular sensor? Strain gauges, again, are usually the least expensive part of the entire thing, and rarely does price become an issue in stress analysis measurements. Don't allow strain gauges to operate above their rated strain limit and optimum excitation voltage. If you do, you may run into some fatigue of the strain gauge. They're going to be rated. You can find that published in our catalogs. Typically, if you start operating a strain gauge above about 2,000 microstrain for a lot of cycles, then you need to start being concerned about what the fatigue life is, and some gauges are better in fatigue than others. Also, with your optimum excitation voltage, make sure that you take a few minutes and you can go through our technical notes, and we'll help you with calculating what the right excitation level is for your strain gauge installed on your test component. It's really a function of the size of the gauge, its resistance, and how good of a heat sink you're putting that gauge on. Don't overspecify. Look at the overall strain measurement system and limitations on accuracy, such as mechanical pipework, vibration, but look at the entire system. Think of the strain gauge as just one piece of a much broader, larger system. And don't assume it will never happen, and never use the strain gauge as a heater. Just like we were talking about a few minutes ago, strain gauge, in order to determine the right excitation level, we're trying to avoid a phenomenon called self-heating, where you put too much power into it and it starts to warm up and it creates a drift, and we don't want that in our measurements. And in general, what I like to do is hope for the best but plan for the worst. So try to play out all the different scenarios that you can where something bad could happen during a strain gauge project, and try to see if you can mitigate that risk, either through the selection of the gauge, the adhesive, or the environmental coating, or some combination of all those. And don't forget to provide adequate protection for the wires near the strain gauge. Water ingression can be a big problem. One of the most important areas when you put on a protective coating over strain gauges is to watch how the wires exit the coating. And you've got to make sure that that environmental coating will completely encapsulate around each one of the conductors. Don't make the wrong wire connections to the data acquisition system or strain indicator, because that can cause bridge balancing issues and can also reverse the sign. So pay particular attention to how your data acquisition system accepts either a quarter, half, or a full bridge. And if you've got one of the micro measurements data acquisition systems, we can certainly help you with the proper input wiring to make sure you get a good accurate measurement. Don't use the wrong shunt calibration resistor value, which causes incorrect span settings. Shunt calibration is your method to be able to set your instrumentation up and scale the output properly as a function of the strain gauge reading. So make sure you pay particular attention to what the value is and where it's being shunted in the bridge, so that you can calculate the value that it simulates, so that you can properly scale your instrumentation. Very important, and it's very easy to make errors at this location. Fortunately for customers of ours that use our micromeasurements instrumentation, we've already taken that into account. So we will very specifically select resistor values that simulate very specific values of strain based off of what type of the test it is or what type of system that it is. Don't apply strain levels that produce yield in the structure, which produces a zero shift in the strain gauges and potentially a weakened structure. So keep in mind, if you start seeing strain levels much above about 2,000 microstrain, you probably need to ask yourself, are you starting to experience, some yield in that structure? Are you getting close to the proportional limit or the yield point of that structure? And that can lead to non-zero return in your strain gauge measurements. So if you are finding that you're loading a structure and the zero does not come back, you need to look at that. Are your strain levels high enough that it could actually have some localized yield in the structure? And if you're doing that, you got to be careful, because probably that structure is not going to do it that many cycles before you go from one piece to two pieces. Don't apply strain gauge or don't apply strain levels that are beyond the capability of the strain gauge or the bonding adhesive, which can cause unintended failure. Typically, you need to select the strain gauge backing and foil and adhesive in order to kind of match the level of strain that you're expecting. So if you're, for example, you're doing a burst test of a steel cylinder and you're going to go to very high strain levels, there are gauges that if you select appropriate ones and use the right installation techniques, that can measure upwards to 20% strain. Not all gauges can do that, but there are a select few adhesives that would allow you to get there. So think about that as you start your strain gauge planning. And don't apply strain gauges to bolted assemblies, which can produce poor zero return after loading. And if it is necessary, watch for assembly loads and the service loads. Oftentimes we find customers will build their own transducers. And one of the things they don't think about is how close they get the strain gauge to the fixed end of the transducer. Typically you want to stay at least 1 to 2 beam widths away from the end, because you can get some edge effects from the bolted end of the transducer. So if your beam, for example, was 1 inch wide, we'd slide the strain gauge down at least 1 to maybe 2 inches to get away from that edge effect, and it basically builds a better transducer that way. Don't assume that your non-zero return is yielding. Are there bolted connections in your structure that might be the cause of your poor zero return? Is it a first cycle event only? Many reasons that you may find that can lead to non-zero return. Sometimes it can be the gauge installation, sometimes it could be yielding, sometimes it could be just the way that a structure is bolted together and the stresses are flowing through it. So you have to pay attention to all those in trying to evaluate, what's causing this non-zero return in my measurement. And thank you for watching. Thank you for taking a few minutes this afternoon, spending some time with us to talk about the do's and don'ts of strain gauge measurements. If you'd like to find out more about strain gauges, take a look at our website at www.micro-measurements.com. Thank you.